For this video, we are tasked to identify the derivative of the given function here, which is f of z identified as e to the power of z squared. Take note that the exponent is another function z squared here. If we have here e to the power of z, we know that there is a rule for the derivative of that to be just itself. But take note, this is when our exponent is just z. But this time, if it's z squared, it's another story. Our exponent is another function. So we can actually express that in this manner, if you would like to. This is just equivalent to e to the power of g of z, where your g of z is z squared. Okay? So that would mean that we cannot just simply invoke this answer and say that the answer is also e to the power of z squared. That is because this is another function. What we're going to use here is the chain rule, or the rule on differentiating composite functions. Okay? Since our given exponent of our e, a base, is also a function itself, we can rewrite this, if you would like to, this given function, since I use f here, let me have it h. Our h of z is actually f of g of z. Okay? Because instead of e to the power of z, this is another function, g of z, which is z squared. Okay? That would mean our result here for our derivative of our given function now, by the way, so yeah, I'm gonna use this as h, okay? I'm gonna use this as h. This is supposedly e to the power of z squared. Our f of z now here is just e to the power of z. But our g of z is z squared. It's when you try to review the rule for chain rule or composite functions, we're going to take the derivative of the entire expression, treating this as 1, and then times the derivative of your function inside. Okay? That would mean we're going to take e to the power of z squared as 1. Okay? That is actually equivalent to itself e to the power of z squared. Okay? Because we're treating it as 1, where we don't consider this as a function. So the first answer is itself e to the power of z squared. Then multiply it with the function inside, or derivative of the function inside. The derivative of g of c is this one here. It's actually equivalent to 2z. Okay? In short, the final answer here is 2z e to the power of z squared. This is the derivative of the given function, which is considered to be a composite function. Let's say our f of z is e squared, and our g of z is z squared, combining them to form h of z. Thank you very much for watching.